All right, so I think we're going to be able to finish it today. Just this section, yeah. We've been on this all week, right? Or no, I guess we did the 10 basic functions first, but today we should be able to finish it. The last thing we're going to talk about in terms of building functions from other functions is inverse functions. And we did this last year in advanced algebra, so you'll go, oh yeah, I remember this. An inverse function, the way that we're going to, the notation that we're going to use in this class is f with a little -1 there. And that does not mean to the -1 power. Okay, that means the inverse. And if you look on your calculator, you have an inverse button on there, a little -1 button. Unfortunately, your calculators will only do inverses of numbers, not of functions. So you have to use your brain to figure these out yourselves. Okay? But you'll recognize this as soon as I do the first example. You'll remember it from last year. Huh? So let's find f inverse if f of x equals x over x plus 1. Okay? So we're going to find the inverse of that function, and then we're going to look at the graphs and see how they relate.
I hated it.
So Taylor remembers that he hates inverses. Does anybody remember how we found inverses? What? Solve for the x? Yeah, so we flip this around. Okay, so we're going to rewrite this as x equals y over y plus 1 was the first step. Switch the x and the y. And then, because that's the idea of an inverse, right, is flipping it around. Okay? And so, technically, we're done, because this is the inverse function of that, but we need to solve it for y first, so that it's written in a form that we know and love. Okay? So, the algebra with this is a little bit tricky. I'm going to show you how to do it. And it's going to come up again, and maybe you'll remember this method, maybe you won't. Any ideas what to do first? Yeah. Okay, good. Let's multiply both sides by y plus 1 because we want to get rid of that fraction. Okay, so x times y plus 1, the key there is that I have to multiply both of these terms by x. So y times x is xy, and 1 times x is x. These cancel, and that equals y. You're lost?
What cancel?
Because I was right.
The y plus 1 and the y plus 1.
See, you didn't do it last time.
Well, Forrest didn't
I have
tell me to
the
stop.
xy plus x equals y.
Okay, so on the other side, I also multiplied by y plus 1, right? Which you can think of as being y plus 1 over 1.
Oh.
So since I have the same thing on top as I do on the bottom, those will cancel, and I'm left with y. Right. Just trying to confuse you.
Yeah. So how did x plus y plus x get there?
Because if I multiply x by y plus 1, x times y is xy, and x times 1 is x.
I forgot we had to multiply both sides.
Yeah.
That's
both
like
sides.
number 1 rule.
Yeah.
Forgot.
Got to do the same thing to both sides.
Okay, now what?
Goes back to class. Okay, now since we're trying to solve for y, you're going to get all the y's on the same side of the equal sign. Okay? And everything that does not have a y on the other side of the equal sign. So I'll do this one step at a time, y times x, xy. Okay? So do you want to get the x over to the right first or the y over to the left? Okay, not quite, no. If I divide, no, I can't do that. So let's get the x to the right. Okay, so these will cancel, so that leaves me xy on the left, and then this is y minus x. Okay? So all I did was swing that x over to the right-hand side, and again, the reason I did that is because it didn't have any y's in there. And it's just like the old gang warfare thing that we talked about when you were in algebra many, many years ago, except now it's the x's that are fighting with the y's instead of the numbers that are fighting with the letters. Some of you know what I'm talking about. Okay, now I want to get all the y's onto the left. So I'm going to subtract a y from both sides. What is xy minus y?
xy minus y.
xy minus y. Not like terms, can't combine them. The y's over here cancel, and that leaves me with a negative x. Okay?
I thought, is that still solved?
Nope, not done.
Didn't think so.
Jason,
Yeah, we
not done. Okay, here's the trick that is going to come up every once in a while in your lives, and I know it's something that you've never seen before, so it's a little bit confusing what I'm doing up here. But what I'm going to do in order to solve this for y is I'm going to factor a y out. Since each one of these terms has a y in it, I'm going to factor a y out of each one. So yes, then that leaves me with x minus 1. Y times x minus 1 equals negative x. And now,
How did you get x?
where did the negative 1 come from? If I factor a y out of this, what's left? A 1. Because this is really 1y, even though there's not a 1. Okay. So now what do I do to get the y by itself? Divide both sides by x minus 1, and now I am done. Y equals negative x over x minus 1.
That's like the worst thing that's done.
Worst thing that's ever happened to you in your whole
That's why I
life.
don't like
Okay? So this thing right here is the inverse of this thing right here. And so what that means is, oh, you think, because that doesn't always work out that easily. For one thing, you flip the sign on this x, you flip the sign on this, but you didn't flip the sign on that. So how would you know when you would flip the sign and when you wouldn't? Okay? So yeah, obviously there's a relationship there because they're inverses, and so things are happening in a different, way, but it's not quite that easy. Okay? So what I want to show you though is pick a number for x.
2.
2, I heard. So if I plug in 2 for x, what do I get up here for y? 2/3. Okay? So here's an exciting thing. If I take and choose 2/3 as my x down here, guess what you get for y? 2. Okay? You could check that if you want. There's a lot of fraction math going on, so I don't really want to do it. But because they're switched around, because they're inverses, if 2 comma 2/3 is on this function, then 2/3 comma 2 is a point on the other function. It is flipped around. Okay? I'll show you the graph in a second after these boys finish. Let's take a look at the graphs.
Are we
Just for
switching
funny.
back to?
You don't have to do this if you want. I just want to show you the relationship between the graphs of the functions. Some of you might be able to come up with this already because of the whole switching the xy thing. You might understand what's going to happen. That'd be awesome. Whoops, this was x plus.
I don't know how to change my pacing.
If you want to go back to the regular graphing mode, you hit the mode button.
And highlight function on it.
And go down until the function is highlighted. Yeah. Okay. So we had graphed x over x plus 1, and then the inverse we came up with was what? Negative x. Don't forget to lead with the negative button over x minus 1. And since there's 2 terms on the bottom, it has to be in parentheses. Okay? So now if we take a look at the graph, we've got some crazy things going on here. That's not really very helpful.
Just the x over.
Let me graph the first one only. Okay, so here's the graph of the first function. Can you kind of see that?
Yep.
Okay, and then let me change the graph of the other one so that you can tell Let's go, you'll go solid line. No, I don't want shaded. Let's go dotted line. There we go. Okay, now you can kind of see, no, not really, the graph of the second function, okay? And the way that these are related, and this is a bad example to show because it's hard to see it, but the way that these are related is that they're reflected over the line y equals x. So this piece right here was one of the branches of the original function, and that got flipped over, and so the branch of the inverse that goes with it is down here. And then this piece right here is a branch of the other branch of the original function, and that got flipped over the line y equals x to be right there. And that's kind of hard to see, so that's not a very good example, but the graphs of them get flipped over the line y equals x.
So that's the f of x plus the y of
The f inverse of x, yeah. Okay? All right, let's do one more since we struggled with that a little bit. See if this doesn't help. Still struggling?
I struggle.
So let's start with f of x equals the square root of x plus 3. And let's find the inverse of that.
Okay, so first,
No,
First
not
step.
yet, hold on.
Nope, not yet. Hold on, so
Change
that
it.
Forrest can write it down.
change our stuff. Okay,
Bueno. Está bien. All right, so this becomes now,
y.
no, it already
X.
was a y, so
X.
this becomes an x, and this changes to be the square root of
X.
y plus 3. Okay, so that's the first step, easy step. Step number 1, flip the x and the y. Now you have to figure out how to solve it for y, and that's going to just depend on how the equation is set up. Yeah, for this one, since the y is trapped underneath the square root, we need to free it by squaring both sides. Okay? Subtract 3 from both sides. And so y equals x squared minus 3.
Yeah, that was much
What?
better.
That's much better.
Like
10 times easier.
Isn't it x
I feel like it's about
equals y
12.5
plus
times
3?
easier.
That's
That's it.
How did
Yeah, why would
So
you
is
go
it
that
gonna
one?
be a
What do you mean how to switch? Oh, I just put the 3 over here, but I'll have to write. Okay. So this is x squared minus 3 equals y.
It's the same thing,
And then I just flipped it around, because you write y equals first.
Oh, yeah.
Okay. Okay, so let's take a look at these, and maybe the relationship between the graphs will be a little bit clearer.
Way easier.
So the first one was the square root of what?
Never in x then.
X plus 3? Yeah, I'm good with that. No, I'm okay with it. And then the next one, when we solved it and got the inverse, was what? Y squared or x squared minus 3?
Yeah.
Okay, so x squared minus 3. And then if I look at the graphs of those, you can see this is the original one, okay? And then this is the inverse. Now we should talk about this just a little bit. Why did this come out to be a parabola and this is just a hyperbola? Because of the square root thing here. Yeah, what's the domain of this function right here?
X minus.
What is the smallest value of x I can plug into that function and still get an answer? I can go less than that. Negative 3. So I could plug in negative 3, and then I could plug in anything I wanted to up to infinity. What's the domain of this?
X squared minus.
Negative.
Negative infinity to infinity, because there's no square roots and there's no division, right? Okay? Technically, and this will only matter to maybe one person in this whole class ever in their lives, since this function right here is built from that function right there, the domain of this one has to be restricted to be the same as the original function.
So that's going to be using like astrophysics or something like that?
Yeah, I'll be using like astrophysics or something like that.
Okay.
Because if it wasn't in the original thing, I can't put it into the inverse thing.
Does that
This
have to have the
thing,
same domain?
yeah, because that came from that. Okay, but don't lose any sleep over that.
They're doing really well.
Just know that
It's actually-
plenty of time for this one.
When 5 minutes, don't give us a big one, please.
So it'd be
Yeah,
negative
you must
infinity
look
to
already.
infinity, Mr. Aldridge? For my astrophysicist degree?
Yeah,
So you're gonna have to tell us, like, if there's anything that we have to equal to y in here, because last time it,
Yeah, I honestly don't like it. I don't wanna get out of
like, you know, said find two things.